welcome or welcome back to our channel. In today's video, we'll be solving a question from LinkedIn where the difficulty level says medium and this question is permutation. So almost all of us have done permutation previously in our schools and colleges, but that was in mathematics. So here what we'll be doing, we'll be solving that similar permutation in means we'll be solving that through our codings, right? So let us check the problem statement. What the problem statement is saying that we will be given an array of distinct integers, and there we have to written like the answer should be saying all the possible permutations, and it can be in any order. The order doesn't matter here. Check it out here. It's written there like it can be in any order. The order doesn't matter here, right? So let us check on example. What the example is saying that input is in array and getting 1, 2, 3, and what as output we are getting like it can be of any possible permutations of these three integers only. It can be 1, 2, 3, 1, 3, 2, 2, 1, 3, 3, 2, 1, 3, 1, 2, 3, 2, 1, like all the possible permutations we need to give. And what it is mentioned here, it can be in any order. So basically what happens, like in permutation we can also maintain order, but in combination it does not matter, like there should not be any order, but in permutation there may or may not be order. This thing we have to keep in our mind even. And check this next example, like what it is given. The array that is given to us is 0 and 1, so there basically can be two only. It's 0 1 or 1 0, right? And in the last example check, only one integer is given in the array, so it's just giving an output only one integer, that is 1. So this is the problem statement that has been given to us. Now we have to think how we can solve this. So one of the most basic approach to solve this is by using backtracking. Now we'll see the approach how we can solve this by using backtracking. Before that, let me tell you one thing, like what we have done in our school and colleges. Like if we have to find the possible permutations of these three sets of integers, what we basically do, we'll just write here in factorial, right? And what you can see here is 3, so we'll write here 3 factorial, and that will give us an answer of 6. So you can check it out here, like there are only 6, 1, 2, 3, 4, 5, 6. There are 6 possible permutations present. That's the entire problem statement. Now we're gonna see how we can solve this problem. So now we'll be saying the approach how to solve this problem. So let us just check this first example what it was given here. Check 1, 2, 3. So we'll be taking that only as 1, 2, 3. So the first case what we can do is we have taken 1 here, and while we have taken 1, two places are vacant, like we can put here any integer as our wish. So either this place can have 2 or this place can have 3. No order is mentioned here. So like it's our wish which one we need to give here. So is given 1, 2, 1, 3. So after 1, 2, the remaining element, what is remained here, like 3 is been remained. So what we'll add here, 3. Because it was said there, check this out even, what it was said, that of distinct integer. So we cannot repeat the integers in our final permutation array list. We cannot repeat integers. That has to be distinct. So what is happening here? Check this. So like no integers has been repeated here. So 1, 2 and 3 is here. 1, 3 and 2 is here. So basically what is happening? We are taking 1 from here. After taking 1 from here, 2 spaces are vacant. Then in the first space, either we can add 2, or what we can add 3. After adding 2, what we can add is, so like let us think. Firstly, we have taken 1. Then what we have taken? We have taken 2. Then what we have taken? After taking 2, we have taken 3 here. So what is the first permutation that we have received is 1, 2 and 3, and nothing is been repeated in this list, right? After we are saying that this, what is the size of the initially given array? The size is 3, and we are checking the size of the finally made permutation, that is also 3. and we are seeing that these two sizes matched. So we will put this one in our final array list. Suppose think of an example that our final array list is named as result or answer anything, and we will put this the thing that we have got right now in the result, this permutation which we have got as a result, we will put this one in our final array list. So this much is done. We have received only one combination, one permutation till now, right? So what are the more possible permutations we can receive? Now the concept of backtracking comes here. What we will do, we will remove this last element. We will backtrack. We will go to this place. We will remove the last element, and then we are in this stage where it is 1, 2, and vacant. Now we'll think what more thing we can add so that it does not matches to this list, right? So we are seeing that nothing more can be added because it's already 1, 2, and only 3 is remain to be added. So we are seeing that it's not possible to add here, right? So again we will backtrack and go to our initial place. Now we will see we have already added 2 here. Now we'll check by adding 3 whether we can add 3 or not. So we are adding 3 here and checking here we can add 3 here. Now we will go to this list. We are adding 3 here. Then we are going to check what more thing we can add. Now we are seeing that 1, 3 has been added, 2 is left. So we are adding 2 here. So this is the next case we can receive, and we are checking that it is already been like the size of it is 3 and the size of this is also 3. They matched, and we will again put this back to our final array list. Then we will again backtrack and check for most, like, all the possible permutations that we can uh, achieve from this given array list. We will search for those things. So for searching for that, what we will do, we will again remove this last element. We will again backtrack. We will see that it's not possible to add anything more here, so we'll remove this element also. We will backtrack again to this place, and we will eventually see that all the possible cases with 1 as the initial letter has been completed. So we have to remove 1 from also here. So what you're going to do now, like, we'll move to this empty list, and now we will check with 2, right? We have to do the again similar thing. After checking with 2, we will go down. First place we have given 2, and the next were vacant. So in the this place we will check what we can put. We will see, like, we can put either 1 or we can put what, 3. So again that similar process, we will be moving with 2 and 1. We will check which one is remain to be put. So we'll see 3. So we'll go again put 1, 2, 1, 3. It will say that it's the size of this matched with this one. So basically we will put this one as a third element in the array final array list, and then we will search for the further more, like, what are the more possible things we can put here. We'll go and check for that one. We'll again backtrack from here. We will remove the last element. We'll see, like, nothing more new to be added. We'll again move from here. We will remove the last element in that permutation, and we will finally move here, and then we will see we are done with 1. Means we are done with 1. Now what the thing we have to put here, we can put here is 3. Now we'll go and check with 3. Go down and put here 1. Then again what will happen, this one matches with the size of the initial list. So we will again backtrack. We will add this one in the final list. We will backtrack. We will check here. Then again this will be removed. We will again backtrack, and we will see everything possible with 2 has been completed. Like, everything possible with 2 has been done. Now we'll again backtrack from here. We'll move to our the initial stage, and now we will check with what, 3. After checking with 3, we will go down, like the similar step as we have done for this 2 also. We'll check for the first step. It can be either 1 or 2. Like, we are going with 1 first, so we are going down. It's like 3, 1, 2. Same thing. Like, it will match to the initial one. It will be the fifth one that we will add. Now we will backtrack from here, and we will go to this stage, and we'll see like nothing more to be added. We'll go backtrack from here again. Like firstly here was 1, now we have what will come here, it will come as 2. Like we'll go with 3 2, then again we will go down with that will be 3 2 1, and we will add this one also, and again we will go back and we'll check like nothing more to be added. Then finally we will go back, and then again we will go back to our like initial stage. Now we will see like everything has been added. So what we have got, this one, this one, this one, this one, this and this as a final result. Now we'll see like all kind of possible permutations that can happen with this list has been considered, and we are done with a problem. So now the thing is, what will be the first step of us? The first step will be like we will add a element from this list. Then we will check what are the things we can add again. Like there will be a function that will recursively call, like limit backtrack, and that will be recursively called. We will do our workings there. And if a case happen that we have reached to the size where the size of the final permutation matches with the size of the given like the initial array, we will just return that one as the like that will be a final output, and we'll return from there. So this is the entire thing. And one thing we need to keep in our mind is, after getting our final result, what we will do is we have to backtrack from the place, and while backtracking we have to remove the lastly added element. That's the important thing. We have to remove the lastly added element, and while removing we have to check like after we have removed, we have to check also like while we'll add a new element, whether that is present in the previous elements or not. So like think that we have 3 1, and now here again we want to add 3. That is not possible, because we have to check in the previous elements 3 is been already added here, so we cannot add 3 here. So if we are having 3 1, the next thing we can add here is only 2, nothing else. We have to check this one and have to keep this in mind also, right? So this is the approach. Now we'll see how we can solve this problem in LeetCode. Let's go here and check this out, the entire approach of solving this. I'll be solving this problem basically in Java. If you wish to solve this in any other language, no issues, but the thing is the algorithm will remain same. So what we're going to do here is we'll see that basically we need to return a list of integer. Why it's a list of integer? Check this out here. The answer we are getting is basically a list of a given list. The thing is, the permutations we are getting is itself a list, and we have to return that lists of permutations. So it's basically a list of list, right? So what we're gonna do is we have to return this list of list. We will just copy this and paste it here. So the final thing where we need to like we need our output to be, think it of any variable. Like I am saying this one is as result, and we will just give our output in this result list of integers. So we have to initialize this one at first. Initialize the new array list here, and then what we're gonna do is we have to create a function named backtrack where we will do our entire processings, right? So inside backtrack, what will be there? Of course, our result will be sent there. Then what we're gonna send is a blank array list. I will tell you why we need this blank array list. So where we're gonna send a blank array list first, and of course what we need to send is nums, because without nums, backtrack will even not know what are the test cases given to us, right? So nums, that's a mandatory one, and after these things are performed, we will just return simply return our result. Nothing to be done here. We'll return our result. Done, right? Now what the thing is, we have to create this backtrack function. How we can create this backtrack function is public, and we have nothing to return basically from backtrack, so that can remain void. void backtrack, and inside backtrack we have to give this list of integer result. We will put this one there. Now what we need to give is we need a array list. Inside that array list, we will just make a permutations. So this list will contain these newly formed permutations. So we need an array list. Give it a name like, I'm just saying this as permutation perm. That is not mandatory in this case. List of integer, like I will name this one as perm. Give it give it any name that hardly matters here. So the list of integers perm, and of course what we need is this nums. Done. And then we need to go to our method. Check this out. Inside this method, what we need to do is the first thing should be we have to check like if the size of this perm matches with the size of this num. See, if the size of this perm matches with this length of the given array, we will simply add that to our final result and we will return from there. So we will check what is if perm dot size equals to nums dot length. What we'll do, we will simply add that to our result dot add new array list perm, whom we will add in our result. Perm, we'll add perm to our result and we will return from here. So basically this thing is also been done like the initial case. What will happen if the size matches with the length, we will return from here. Now what we need to do, we need to like think of this case. Firstly we are adding one, right? So again here also we'll do that one only. We'll take first element from the array and we will add that to our new perm. So what we can do is we'll run a loop here from int I equals to 0 and run that to the length of nums, right? So nums dot length and I plus plus. This is what we will be doing. And now what we will do is after we'll take the first element and add that to our perm. So simply perm dot add. What we'll add? We'll add our first element. The first element is nums of I. We are adding our first element here. After we have added our first element to this, now what we need to do, we need to call backtrack for performing this entire thing and for searching the further possible things in this everything. What we can do, we will again call our backtrack and here we will send our result, this newly made perm here, and we'll send our nums. Backtracking is done. After performing backtracking, what we did there, you can check this out here, like we will remove the lastly added element. So now what we need to do, after backtracking we have to remove the lastly added element. To remove the lastly added element, what we can do is perm dot remove, and whom we will remove, we will remove the last element. To checking the last element, what we can do, we can check the size of perm and then minus 1. That will give us the size of the element. So what we will write here is perm dot size minus 1. This will give us the last element, right? So we have removed the last element. Now what we need to do is we will check whether this element is previously added or not. You can see it here. If we are adding 3, we will check whether 3 has been added here or not. We will check, right? So what we need to do here is we have to check. What we can write for checking is if we'll check perm is previously containing any of the like if perm is containing this element or not. So from where we'll get the element, we'll get the element from nums of I. So we'll check if perm is containing nums of I or not. If perm is containing this element, what we will do, we will simply continue. Right? We will simply continue. And we are done with our thing. So that's the entire code. That's the entire code. And basically it's really simple. You just need to understand the approach how to solve it and then you can do it in your own even. Now let us run this and check if any problem is there or not. So see, all the test cases have been accepted, so it's completely working and we'll submit it and check. See, it's running absolutely fine. So this is the code and this is how we can basically solve this permutation problem using backtracking. And if any of you is having like any other optimal solution for this problem, comment it down below and let me know like how we can solve this in other ways also. And in next day we will learn how to solve any problems of combination. Today I've done permutation, the next day we will learn problems like how we can solve combinations too. That is also one of the like favorite questions of every MNCs, I would say. And yeah, that's all for today. See you in the next session. And if you like this video, don't forget to hit a like, subscribe to my channel, comment down if you are finding any optimal solution. That's all for today. Thank you.